Making a model of the Empire State Building requires skill and a lot of knowledge about finding measures in similar figures. Today, you will learn how to identify similar figures using their corresponding parts. You will also learn how to use the fact that two triangles are similar to find lengths of missing sides. What are similar polygons? Two polygons are similar polygons if corresponding angles are congruent and if the lengths of the corresponding sides are proportional. If you look at the diagram in the middle of this key concept, you'll notice that angle A and angle G are the same color, angle B and angle H have the same color, angle C and angle I are the same color, and angle D and angle J are the same color. That means that those angles are corresponding angles and they are congruent because they have the same exact symbols. When you're writing an extended proportion, this will tell you whether or not the lengths of the corresponding sides are the same or the ratios are equal. So segment AB from A to B and G to H is forming a ratio. BC to HI is forming a ratio. CD to IJ is a ratio. And AD to GI is a ratio. And since we have four sides and four angles, there should be four ratios to form the extended proportion. Quadrilateral DEFG is similar to quadrilateral HJKL. What are the pairs of congruent angles? Well, the similarity statement is already set up according to its corresponding angles. Angle D is congruent to angle H. Angle E is congruent to angle J. Angle F is congruent to angle K. And angle G is congruent to angle L. If we want to find the extended proportion, it is also set up according to its corresponding sides. So the first two letters. So the ratio would be DE over HJ is equal to the second two letters. EF is over JK. The third and the fourth. So FG over KL. And since there are four sides and four angles, there's one more ratio that I can write, and it would be the first and the last. So DG over HL. Are the triangles similar? If so, write a similarity statement. Find the scale factor. Well, in order for us to figure out if these two triangles are similar, we need to make sure that their corresponding angles are congruent. So notice that angle A and angle X have the same exact symbols. So that means that angle A is congruent to angle X. Angle B and angle Y are right angles. So angle B is congruent to angle Y. All right angles are congruent. And angle C and angle Z have two arcs. They're the same. So angle C is congruent to angle Z. So far we see that corresponding angles are congruent. Now, in order for these two triangles to be similar, their corresponding sides, ratios must be the same. So we're going to set up a ratio of segment AB is to segment XY. So 15 to 6 equals 20 over 8, which is equal to 25/10. Now, to see if these ratios are the same, we can reduce these fractions to lowest terms. So the first fraction can be reduced to 5/2. The second one can be reduced to 5/2. And the third one can also be reduced to 5/2. And since all ratios are the same and the corresponding angles are congruent, then these two triangles are similar to each other. And the similarity statement would be triangle ABC is similar to triangle XYZ. And the scale factor is 5:2. Now, to understand similarity a little bit more, here we have two triangles, and we're told that the two triangles are congruent to each other. Or really, they're similar to each other because of that symbol that's in between the two. So we want to figure out, well, which angle is congruent to which angle, and what would the extended ratio or the extended proportion be. So angle M and angle S are congruent to each other. So we're going to put the same symbol within the angle. Angle N is congruent to angle R. Same symbol. And angle P is congruent to angle T. So the corresponding angles are congruent if these two triangles are similar. The extended ratio, segment ST, is to segment MP, which is equal to segment TR over segment PN, which is equal to segment SR over MN. We want to determine whether or not these two figures are similar to each other. The very first step that you want to deal with is identifying the pairs of congruent angles. So as we can see, look at the symbols within the angles. Angle J is congruent to angle T, same two symbols. Angle K and angle U are right angles, so they're congruent. Angle V and angle L are congruent because they have the same three arcs. And angle W and angle M are congruent because they have one arc. Now we also need to figure out if the ratios of the corresponding sides are the same. So let's look at the length of MJ and the length of WT. Those two sides correspond to each other. So the ratio would be 6:6, which is 1. All of the other ratios of the sides have to be 1. And if they are not, then the two figures are not similar. So look at from J to K is 12, and T to U is 6. But 12 divided by 6 is 2. And since 1 is not equal to 2, the ratios of the sides are not the same. Therefore, these two figures are not similar to each other. Now, when you're finding the missing side length of two similar figures, you still want to keep in mind that the corresponding angles are congruent and the corresponding sides are proportional, which means that the ratios of the sides are equal. Here's an example of how to find the missing side lengths of two triangles. We're told that these two triangles are similar. Determine the value of X and Y. So if a side length is missing, what you want to do is set up a proportion to solve for the unknown. So if you notice, there's a little box in angle A and also in angle R. That means that those two angles are congruent to each other. And then there's a circle in angle B and a circle in angle Q. Those two angles are also congruent to each other. And all you need to know is that you have two pairs of corresponding angles congruent. Therefore, the two figures are similar by what is known as AA. So now we can set up an extended proportion and then substitute the numbers and the variables back in the place of those links to find out which two ratios we would set equal to solve for X or Y. So if you notice, AB is X and RQ is 12. So we wrote a ratio of X over 12. AC is 35 and PR is 10. So we wrote a ratio of 35 to 10. And then CB is 49 and PQ is Y. So we set up a ratio of 49 to Y. So now in order to solve this, you have to make sure that you have one complete ratio, which is 35 to 10. And so we can take that ratio and set it equal to X over 12. And if these two ratios are the same, then their cross products are equal. So what we can do is either the bat and the ball method, or we can use the cross product method. So we want to know what 12 times 35 is, and then set that equal to 10 times X. So we end up with 10X is equal to 12 times 35, which is 420. Divide both sides by 10, so X is equal to 42. And you want to do the same thing with 35 over 10 is equal to 49 over Y. Cross product should be the same if these are proportions. So 35Y is equal to 49 times 10, which is 490. Divide both sides by 35, and so Y is equal to 14. We want to continue solving for the unknown length by looking at these corresponding angles first. Notice that angle B and angle E are congruent to each other, and we're told that these triangles are similar. So if I were to rotate triangle DEF counterclockwise 90 degrees, you'll notice that segment BC corresponds to segment EF, and segment BA corresponds to segment ED. And if these two triangles are similar, then we can set up a proportion and get ready to solve for the unknown. Segment BC is going to be substituted with 30. Segment EF is 15. Segment BA, going to substitute 36 in the place of segment BA. And then ED is what we're looking for, so that is X. So if I want to find out what X is, cross products are the same. So 15 times 36 should be equal to 30 times X. 30X is equal to 15 times 36, which is 540. Divide both sides by 30. So x is 18. Now these two triangles are attached, and they are attached by one point in the middle. We want to find the values of x and y. So think about taking the triangle that is labeled with the x, the 5, and the 8, and rotating it 180 degrees, either clockwise or counterclockwise. If we do that, then 8 is going to correspond to 12. So there's our ratio, 8 to 12. If we keep on looking at it, now we see that 5 is going to correspond to y. And then the last ratio that we can write in this case would include the x, which would be x is to 15. So in order for us to solve for x, we must use a complete ratio and the ratio that has the x. So 8 over 12 is equal to x over 15. This time I'm going to use the bat and the ball method. Circle the bat, multiply, divide by the ball. So 8 times 15 is 120. I'm going to divide by the ball, which is 12, so x is 10. I want to do the same thing for y. But this time, instead of me using x over 15, I'm going to use 5 over y is equal to 8 over 12. Circle the back. That's 5 times 12, which is 60. Divide by the ball, which is 8. So 60 divided by 8 is 7.5. So y is equal to 7.5. Now the last two triangles are also similar to each other. We want to solve for x. So think of this one as being like a translation. If I take the triangle on the left and slide it to the right, you'll notice that 30 and x are going to correspond to each other. So 30 is to x as 15 is to 12. Circle the back. 30 times 12 is 360. Divide by the ball, which is 15. And 360 divided by 15 is 24. So x is equal to 24. So now that is it for this lesson, and I hope you understand how to set up a proportion and actually solve for one and solve for the missing sides. Please make sure you go to the assignment and you complete the assignment number 3, which is similar figures, and make sure you turn it in by Thursday, which is April the 2nd. Have a good day.